Hi there guys, we're back on the bench. As you can see, I did a bit of a cleanup on the bench, so for later demonstrations where people would say there were X wires used, well, that will eliminate it all. So here you have the yoke with the MOSFET push-pull driver. I still have to fix it, as you can see, the ICs and tuning knobs and everything. Some other Tesla coils and aluminium split right there, so we can use. Here you have the mediator again. We'll not be using it for now. The only thing that we will drive today is the Kacher. So this is how my Kacher is wound now, after succeeding the effect. It's basically the same length as the grenade, as you can see. Comparison to my hand, here we have the ferrite piece, which makes the unipolar impulses that we'll be using in a particular experiment. Okay, here I have my Kacher, a series of bulbs right here, with fluorescent connections to my Kacher are here. We'll be starting off with a 12 volt battery. Afterwards, we'll be starting with the PRCO, which is 24 volts. Okay, so what will happen now is we're gonna be using iron plates. So I took an example of tin cans. So this is one size, bottomless, and the other one I've placed a new antenna around it, as you can see. It doesn't need to be nice, but it's an antenna, the end, which is isolated with black tape. There's no other way it could make connection. It's hollow, just as the one, same direction. So what we'll do is place it inside. Okay. Oh, even the edges of the tin can here, of the smaller one, is also being black taped. So there's no other way it could have contact with the down part of the bigger one. So see as these as an example of the grenade and the inductor lines. So that I'll be showing today. What we'll do now is connecting the ferrite piece. Sorry. Like that. Connected the ferrite piece to the antenna, and the antenna will start to create an electrostatic field. There will be potentials between the plates, positive force and negative force. What we'll do now, here we have one alligator clip lead in the positive force, and there's a negative force right here. Okay, so we're starting with a 7-watt bulb. Here we have a 25, and here we have a 40-watt bulb, if I'm correct. It's right there in the inscription. 40 watts, 120 volts. Sorry about that, the dogs are acting up. So this is my Kacher. There's a bit of foam spacing. These are the windings that I'm using currently. No thicker inductor for now. Okay, I'll be starting the system now. Oh, and before we continue, I have a ground, the same ground line, as you can see. It's connected right there. This is also a separate ground connection where I have plates under the sand a bit further there connected to this rod. And there are different types of manifestations. Okay, let's start. Okay, turn it on. You see somewhat bulb is barely on. It's been connected to the two potentials. As you can see, if I disconnect one, it's still using the lead as an antenna. The moment I disconnect one of them, it's dead because it doesn't react as an antenna anymore. Now it's on. Now we connect it back to the plate. You see it's a slightly bit brighter. Right now what we do is we connect ground. Now before touching the negative, I want to touch the positive side of electrostatic field manifestation. See, it kills the load. As you see, it's inside. Now I'm touching the negative. As you can see, it gives more load, more pump. So this is very important. Now I'm gonna leave it on the negative. As you can see, it's running beautifully. This is the negative. Whoopa, sorry. The negative line, this one, all the way here to this. As you can see, now it's brighter. So now even the Kacher's negative is connected to ground, and you see a brighter manifestation of light. Now let's see what happens if I disconnect ground. Disconnect it. You see it dimmed a bit. Now touch it back. We can barely see something from here, but it's actually riding it up a bit. Now I'm gonna be placing it on this pole, which is just my tent. Okay, look what it does. It does weird effects. It's like it flickers, or it actually generates even more than the ground itself. Okay, I'm gonna place it back. Okay, as you can see right now, I'm disconnecting the ground. Here we have a CFL. CFL is like turning on a bit, as you can see. Not too much. As you can see, it's right there, it's turning on. Now if I could connect one of these leads of the plates to the CFL turns on. And with that, now with the ground connected to one of the leads, kills the CFL, eliminates RF and creates more load for bulb. Do the opposite direction, kills both of them, because this lead is the positive force of what is happening here in the electrostatic field. This is concept for the grenade, where to put on which ends, on the lower part of the grenade as a Tesla coil, or on the upper part for better effect. This is something you guys need to know. See, there's a positive force, the negative force being connected. You see, it's purely induction. So what happens is, when I connect plus the negative force back of the bulb, see, it turns on. But now if I go with the CFL, It doesn't turn on anymore. See? No more. And the bulb is still on. It's only Kacher working. See? Look, if I disconnect, see? If I connect it back, this is the only way it's working. I hope this is one part for understanding. Now I'm gonna be switching to the 24 volt power supply just in a bit. Okay, wait, let me connect that back. We'll be using a 7-watt bulb for the moment at the ground at 12 volts. Now we turn on the system. It's on. You see power is moving from ground and to ground via the wire. Even if I remove it, place it on the 10th pole, which is not connected into ground, it's just on top of it, and you see manifestation. Okay, we leave it there. Now placing a bit of juice right there of the negative of the Kacher. That stays the same. At the moment I remove power from this, you see power is more here at ground. So you see potentials vary in 12 volt system. Okay. Wait a moment, I'll be setting up the 12 volt system. As you can see. Wait. There's really nothing coming out of the ferrite yet, but out of the tips though. Okay. Okay, I managed to set up the 24 volt power supply, as you can see, with the blocking diode. These are the resonant caps I got a few months ago. I have 2 of them. Those were in use when I had the effect in the very last try, but that will come about later on. See, we have the ground connected to the negative plate. The positive plate is connected to nothing. The leads are connected to nothing, as you can see. And we'll be showing you in connecting a 7-watt bulb to the ground. And to eliminate ground loop as thoughts, well, we'll be lining it up against this pole, which is connected to nothing, and a aluminum slit. Alright, with my bare hands and barefoot. Okay, so now we'll be turning it on. And you see 7-watt bulb is completely lit. Just connecting the negative side. So disconnect it. See, there's no light right now. It's lit. Now look what happens if I try to light it up like this. See, it's completely lit again. Now I want to light it up with that. So what I'll do is, see, with my bare hands, there we go, completely lit, with the ground only and the plates. See? No difference. So what we'll do now is I'll turn off the system for a while, or no, will not. Let me disconnect the ground. Disconnect the bulb. So we'll leave the ground just normal. As you can see, no bulb. I just want to show how the ground is working. It's for the learning process. Now connecting 7-watt bulb in between the negative and the positive force of the plates. As you can see, it's not completely on, maybe 50% or less, not like how the ground worked. Now connecting ground wire. Look what it does when connecting to the positive side. So the positive side turns on just a bit. It has a weird characteristics. But what happens to the positive side right now? Look, completely lit. And I hear the power supply screaming a bit. So what happens is I connect ground right there, and I have the ground emitter side of the Kacher. Nothing. Yep. Turn some brighter. Okay. Now connecting. Whoop. There's one more thing you need to do. If you have a ground connected to the negative side and you remove the bulb, you'll hear like a lot of hissing noises going inside. It's you'll see all radiant arcs inside of it, all of it, and it will burn everything. Smoke will start up here. So best thing is to disconnect. Okay, so right now that was a 7 bulb. Now a 25-watt bulb for the Exprmnt. Ow, that hurt. I think I burned my hand. Ow. Okay, now with the ground at the negative. Now the negative turns it on like completely, but the positive barely. So it's literally the opposite of the 7-watt bulb. Okay, see? On the negative. Look what happens if I connect to the negative. I leave it like that. It's completely lit, almost completely lit. Disconnect the ground. Gonna disconnect it. Look what happens to the bulb. See, it brights up a bit more. And if I connect it to the pole, look what happens. Brights up even more. But if I connect to the ground, it actually doesn't give too much. See, it kills it weirdly. Now the pole. Okay, sorry about that. It was an airplane. So, okay, as you can see, with the ground, it gives amplification. Without the ground, it's nothing. But with ground, it turns on. But on the negative, on the positive right now, there's barely an amplification. See, positive. But on the negative, it does beautifully, as you can see. Leaving it here on the negative. If I should disconnect the ground, you could see. Now connecting it here, you can see it amplifies the light. Right. So right now, if you want to see a radiant, there ain't no radiant, but maybe on the testicle just a bit, you see, and not so much. But the moment I remove the ground, radiant is available. There is Radiant everywhere present. At the moment you connect the ground, there we go, nothing, absolutely nothing. And 25 microwave bulb. Okay, what I'm gonna do right now is connecting a turn this off. We're gonna be connecting a 40 watt bulb, like how Sergey used in instructions on 20 volts, 40 watts. Okay, positive and negative potentials of electrostatic fields. Connecting. Turn the Kacher on. Yeah, it's on. Right now we don't see nothing, but look. See those? Those are corona. It only lights up with the corona because it cannot form the necessary loading. So what happens now if I put the positive on the ground? Kills it, see? Turn on the corona again, now on the negative force. So it turns on the 40 watt bulb, barely, maybe on 30%. What we're gonna do is leave it there. See, no radiant, as we know it already. Now what I'm gonna do is to show you difference. Disconnect ground from ground, and see when I disconnect it, there's no noticeable difference. It's just open as an antenna. Now connecting it to the pole, look what happens now. See? Look. So we're gonna be leaving it on. Wow. Would you look at that? Oof, that's hot. Yeah. No Kacher. Maybe on the Kacher a bit. Uh-oh. We have burn. Have to stop it. Let me see if it's okay. Yeah, that's alright, that's alright. Wait. Basically it's firing up. Yep, there's smoke. Oops. Oops. Wait a minute, wait a minute. That should have not happened. Okay. I think it's good to go. Nope, nothing. Okay, we're back with the coronal discharges, with the ground, turning it on the negative pole. Turns completely on, as you guys can see. Beautiful. Only with the ground. Disconnect ground, nothing, only corona. Connect ground. You can hear the beeping coming from the PSU, sorry. Now connecting a 7 watt bulb. There we have load. Here we go. Beautiful. Dips it just a bit only, but nothing too much. Pretty good. Okay guys, I guess this is enough for tonight. Just a bit warm. That's handling it. That's pretty good. Well, I hope this was enough to show you guys what it all was, with the ground and everything, and soon we could synchronize this all again with the mediator, the Kacher, and the push-pull system. So now you guys all know this is was an experiment conducted with 2 plates and the antenna using the unipolar Faraday piece converter. This resembles this entirely, just in a small part. So this is my grenade, as you can see, my Kacher. Nothing inside. Okay guys, let's see what we'll be up to afterwards. Laters.